We are going to create a CameraX app. So you go to the documents, you can see the use cases. We are going to use two use cases. One is preview, implement preview. So we will have preview of the camera preview, and we are going to use another use case of capture image. And go to Android Studio, create a new project, empty activity, and CameraX, and we are going to save in desktop. So importing, and you can see there's full use cases. One is the image preview, and one is capture image, and analyze image, and capture video. We are going to capture image and show the image preview. Okay, so importing. Okay, it's loaded. And go to the app module of the Gradle, and this source compatibility, which will be version -1-8, and this also be target compatibility. It's be -8, so the Java JVM target, Kotlin option JVM target will be 1.8, and so we need the dependencies. So you can see we need extend icon for material icons, and we need CameraX dependencies, which generally camera call, camera tool, camera life cycle, camera view, and we need a Jetpack compose and CameraX integration, which is camera view 1.3, and we need a view model and live data with compose. Live data, view model, compose. We need coroutine, Kotlin coroutine, Android, and we need permission handling. So this is accompanist permission, and for synchronous image loading, we use coil. and we can sync it. So go to Kotlin plus Java and our project. We are going to add some package of UI. Oh, okay. Oh, this is UI.theme and a new package of screen screen package, and we can add a new package of view model. We are going to have MVVM view model, and add another package of model. Okay, so our project is synced, and we need set the permissions. Manifest. We're going to manifest, and we add use feature of camera.ini, use permission of camera, use permission of write external storage. Okay, set up this manifest, and we are going to add a new model. We create a new Kotlin data class. Data class we call it image capture model. Image capture model, which will be have image URL, and which type of URI, and now above the default value to now, and we have file now by default to now, and we may have error, so we say error of screen now of default value to now. Okay, perfect. So we just have our image capture mode, and let's run the application first. Okay, so it's running. So let's go to screen at our camera screen. So Kotlin, and let's say camera screen, and this will be function, and this is composer. Oh, and which the camera screen. The camera screen, we need a dependency to the view model. Which is camera view model, and we go to view model, create a new camera view model. View model. Let's say for this camera screen, we need launch the effects. Let's say launched effect. Launch the effect which have the key one, which is unit. And this launch effect, we are going to check the permission. Not camera. Permission state. Camera permission says our local variable. Oh, camera state, which equal to remember formation. And this will be manifest. Manifest. Manifest dot permission dot camera. And there's no status, but let's run it. And we will see Do you remember permission state? Remember manifest? HMV and remember permission states. So this is that experimental permission API. So it's remember permission state launch select and camera permission state. Permission state is grounded. And if in this case we just say camera permission state dot launch permission request. Okay, so this is our camera screen and camera view model. Camera view model will be view model, inline view model, and in this view model, so right now we just implement the view model and go to our main activity. We say we don't need rating, don't need rating. And we have the local variable private view model, which is camera view model, our camera view model, and this is by view model. Models and so for uncreate invalid content and this is surface. surface. Surface, we'll say modifier equal to modifier x, and we need a color equal to interior in color scheme background, and this is a camera screen. We pass the view model equal to view model. Okay, and this surface is surface. Okay, and for this, and we can run our application. Basically, we have camera screen, and when it's launched, we check the camera permission state, and this is which is the experiment permission API. We check the permission for us. No permission, we launch the permission request. Okay, so perfect. So right now, when the application started, and if there's no remember permission state function, it calls this. So this is the Jetpack compose companies permissions. Remember permission state function, it calls to this, and the camera permission state this which equal to not grounded, and it launched launch permission request. So it launch permission request. We click on while using this and it loads that our camera screen. Perfect. So this is the permission part. Go to our So remember, we need a camera preview, for which we're using the CameraX use case of an image preview. And we need a capture image. So let's go to the view model. You can see we need to have let's say capture image. We need image capture object. Let's say go to our view model. We can say private variable var image capture, which is type of image capture camera.com is camera.com, and which is default to now. Okay, so we need so to set up the camera, create a camera provider, and create a image capture. We need an image capture object, and so let's say our view model will say have a function, a provide function of, let's say, create image capture, and this will return image capture. And in this, we'll say a return oh, we return image capture. Image capture. So this image capture object, we use image capture, the camera call image capture class, the builder, and we set target. No. Actually, we just say set capture mode, and this capture mode will be say image capture dot. It has capture mode, minimize the latency, so low latency, and build. The builder build it, And also as an image, our local variable image capture, which will be equal to 8. So this will pass this image capture to our local variable, and we also return this capture. Okay, so this create image view models create image capture, which this will return the image capture object to our screen. Okay. And let's go back to our camera screen. After the permission check and permission request, so our screen will have a camera preview and a button which click on it will capture image and show image. And okay, so let's say we have a box. Box is a modifier equal to modifier and fill max size, and we will say if our camera permission state and status is granted. If it's permission granted, and we say we want to have a camera preview as camera preview is modifier equal to modifier fail max, and we'll pass the view model equal to view model, the pass this view model and we need to create the camera preview. So let's say add all possible and fun of camera preview, and remember we have two parameters, modifier of modifier equal to default modifier, and the view model is type of camera view model. And now we work on this view model. Now we work on this camera preview. Let's see. So take to add image preview, we need to request a camera provider. Like okay, so this we can say launch effect. When this view is launched, launch effect. Launch effect. No. Launch effect. Launch effect. And P1 will be, we say, camera selector, and this camera selector, which is a wall constant selector, and this is remember. Remember camera selector. So this is camera.com, camera selector dot default to back camera. And this camera selector, which equal to remember. Okay, so we import the run, and so this will be because for the reactive screen, and this is I remember use the remember to be that the UI will respond to the value tree. And remember this camera set dot default background. This launch effect will say P1 will be equal to the camera selector select this default back effect, and it launch the camera provider, which equal to context dot get. We need a variable of context. Index equal to local context dot current, and this context dot get camera provider get camera indexed dot get camera provider. Context, which is local context current, and context dot get camera provider. Get camera provider. Okay, so this get camera provider. Yeah, it's this is the function we are going to say suspend context extension into the context get camera provider function, and we should say type of process camera provider, and is equal to suspend coroutine, and call and continue station goes to process camera provider dot get instance, and this contact this, and also post future post the future dot get listener. So provide camera provider, and this will have a process camera provider. You get an instance, and they bind to this contact list, and this had a listener. The listener will be say continuation dot return and future guide. And the second parameter is context compile dot guide when execute this. So this will get camera provider, and we set the main executor to the context of this, and we see the listener of this camera provider to future locate. And so this we have the camera provider, and we need to say image capture equal to view mode dot create image capture. So we have image capture, and local image capture have, and we say camera provider dot unbind now, and now we bind camera provider dot bind life cycle. We bind this. Say we need a life cycle owner. So we can say life cycle owner equal lifecycle owner, and the lifecycle owner equal to local lifecycle owner current, and the first parameter is lifecycle owner, and camera selector, we need a preview or preview. This is the preview from androidx.camera.com preview, which equal to remember of preview dot builder. It has a preview class, has builder dot build. So we call this preview builder dot build, and this is that the preview. We bind this output lifecycle. And the false, we need image capture. Okay, and we cite that preview site surface provider, and the service provider will be we need another variable, so we say more preview view. This need a view equal to remember of preview view, and we pass the context to it. And so this preview is set service provider of preview view, local preview dot surface provider. Okay, so now we have our camera provider, and we run our application. It should show the camera view. And show the camera. Oh, okay. This is in the launch effect of camera selected. So then we can say undeployed view, and this central view the factory, which equal to preview view, and modifier equal to modifier. And now we can see the camera preview. Okay, so now we see the camera preview on our camera screen, and we need the button to save the image. So basically, you need get the camera provider from context get camera provider. This contact camera provider is extension of the context, and we should return the process camera provider. And you have a camera provider, process camera provider, and then you bind this to life cycle. This bind to life cycle need a life cycle owner, and basically it's local life cycle owner dot current camera selector, and that's the camera selector preview, which is from the call camera.call, and has preview class as a builder, and you call the builder function, and you will have a preview. And the image capture we got it from the view model. Create view models. Create image capture. And now and so after that you bind this camera provider life cycle, it's bind these two, and this preview you can set service provider to that you have preview, and this preview is also from that camera call and pass the context, and you set the service provider, and then you return unjoined view factory of preview view, and it will show that camera preview. So this is the first use case of an image preview, and next is capture image. And let's go back to the camera view model. We set up live data. So we say we private for local variable image capture result, which equal to mutable live data, mutable live data, type of image capture model, capture model, image capture model, and so pass to the public image capture result. The public product image capture result equal to live data of type of image capture model, image capture model, and this equal to our image capture result, live data input. Okay. Okay. And to click on the button and capture image, we need a private plate image. Of CameraX, which is type of executors. And so our view models in it is a camera executor, which equal to executors you new single thread execute. I need a camera executor. And so we need an override by uncleared. Uncleared, we say super dot unclear. Super unclear, and also we need camera executor. We need shutdown. So now we are able to create the function capture image. So function capture image, which need a context type of context. And so basically, this capture image use case, we need image capture. Image capture, which equal to image capture, and if there's no image capture, we will return. We need image capture. Remember, you remember we create image capture and we save it to local variable, and we need this saved this local variable. If there's no image capture, we cannot capture that image. And in this, we need a coroutine. This is because it's external camera service. We need a for asynchronous operation. We need a coroutine. Let's say view model scope launch, and basically they say this will be image capture. We call the local variable of image capture. Image capture dot take picture, and this take picture. What do we need? I need up to out image capture dot output option executor image capture dot callback. So let's say we need first we need output options. Output file options, and this will say raw output options equal to, let's say, if build dot version SDK int greater than build dot version dot version host dot queue. So this is that version 29, and in this case, yes, else. So else is for device running Android Iceland Q 29. Right? And for greater than Q or called Q, so this for content result equal to context dot content resolver and we say content. We need the image. We need to put it into the content URI, and this we need to will be media store image media external content URI and image capture dot output the file options dot builder, and we need to pass Base builder, what do we need? Content resolver. We need pass content resolver. Content resolver. Content URI. And content values. We need content values. For content values equal content values dot content values apply and this content values we need put media down dot media colors dot display name, and we need a name. We need var name equal to sample date. Oh my. And this will be dash dash dd hh dash ss sss and local dot us dot format system. So this name will be that system dot current tab, and we get name from the current tab. And we put it in the name over here. So that content value, put in this name over here. And we also need to put media star. Media columns dot MIME type, and this will be image slash Jetpack. And if the build, check the build dot version dot SDKInt greater than build dot version code dot e is 28 was greater than 28, and we can see we can if greater than 28 we can put media style dot image dot media media dot it has a relative path, and this will be pictures CameraX images. We put it into CameraX images, and so now we can have that the image capture output options, the builder, and CameraX and content values. So content values over here, and then this we call it the build function. Build it. So, or else we say for picture DDR picture DDR equal to environment dot external storage public directory, and then this will be environment dot directory picture, and for photo file equal to file. This is a file of picture there, picture, and the name will be $, curly bracket, name dot Jetpack. And this use image capture dot output output file options builder, and we put this photo file and build. So output options. We have this take picture there. We need to pass this output option as a first parameter. And the executor will be context compile dot write my executor of our executor. Of context. And on the callback, we need an object of image image capture callback. We need this callback, so what we need is on image saved and arrow. So we say override one image saved out which will be image capture dot output yes. And is our saved URI. We pass the saved URI to output saved URI. Results URI. And so we cite our image local image capture results dot value. Set this to image capture model, and this image capture model, this image URI equal to this saved URI. So basically it overrides our image saved and on error override one on error and see image capture and this we set the error. So image capture result dot value equal to image capture dot image capture mode. And let's say error equal to photo capture failed, and while pass that exe.message, and alright, done on image saved. Alright, on image saved, output image. Oh, actually, is on image saved callback. Okay, so this is on image saved callback. Capture and saved callback, and we return that saved URI to our view models image capture result. And that's our capture image. So basically, it only uses image capture object, and let's take picture method, and it need output option, basic output option, which we need specify media URI, and the main media URI which need contents value, which need a display name, which should have a name, MIE type, contents value which have MIE type, and if it's that version greater than 28, we have relative path. So basically, provide output options. So that's which is the folder, that image files folder, and the name, and the executor, which will get the main executor from the context. And on the callback image capture, on image save callback, we have the URI passed back to the view model, and the view model will pass this saved URI to our screen or other yeah, to the UI, and that's the view model. And we can go back to camera ring. We can say the camera preview, and we have camera preview, and we can say we have an icon button, and this icon button is modifier equal to modifier dot align. We align to this bottom of alignment. Bottom center, and padding bottom go to 32 dp, and size go to 72 dp, uh, modifier dot align ID size order s2.dp color white, and and on click equal to view model dot capture image, pass the context equal to we need all context equal to local context of current, and icon for this button, image vector dot icons default dot camera and content description equal take photo and color dot modifier of 36. Okay, so now we can take the picture. And we click on this button, we can take the picture. But how can we check it's saved? So let's see, we go to device manager and we're running and we go to storage, go to save, primary, pictures, and CameraX images, and 2025 March 18, and we have this picture to be taken. We take a photo and save the capture image, the capture image to the file, and that we have saved the image. Then we return that image to view model. So the model of capture image of that URI. We have that URI, and so now we can say capture result. We need we can have more. Capture result equal to this is by reactive view model dot image capture result dot observed state, and so under this view mode button, we can display this captured image. The capture result. This is nullable, and we check it. We check if it's not nullable. So this image URI, and if it's not nullable, we use the light to check that it's not nullable. And if it's not nullable, and this we say URI goes to and we say async image, put it to async image, and this async image. And async image model equal to URI content description equal to capture image and modifier modifier and a align to alignment dot auto start. And the ID of 16.dp size to 80.dp folder, and there will be 2.dp and color white. Okay, so now we can display this capture image. And it display this capture image over here. Okay, so you remember if that camera protection is grounded, but is not grounded, what we need to say is column and a modifier equal to modifier dot fill max. It's still running. I don't need to stop it. And vertical alignment will be alignment of alignment to put content in the center, and horizontal alignment dot alignment center horizontally, center horizontal in the vertical and horizontal in the center, and the content will be text, and let's see, camera formation is required, and we have button and the button on click equal to camera dot request launch permission request, and on click modifier which equal to modifier padding of 16. And this will have text of the button saying request permission, request permission. So right, and that's our alignment arrangement of center. And so that's all for our CameraX Kotlin compose. So we have camera preview, we have button to take picture, and we save it into our picture folder, and we have showing the image of the saved picture. And yeah, so that's the CameraX.